Also to show and explain why dioxins are guiding parameters for other unintentional POPs. Then in part 2, I will introduce the methodology to establish comparable dioxin inventories with the UNEP Dioxin Toolkit, the updated 2013 version, and finally some conclusions for inventory development. In the beginning of the Stockholm Convention, of the 12 POPs, 4 of these original POPs were unintentional POPs listed in Annex C. So these were polychlorinated dibenzodioxins, PCDDs, polychlorinated dibenzofurans, PCDFs, polychlorinated biphenyls, PCBs are also unintentional formed, but the main amount are intentional PCBs. So here you need to describe between unintentional PCBs and intentional produced PCBs. The same for hexachlorobenzene. And then in 2009, pentachlorobenzene were listed and added to Annex A and C. Polychlorinated naphthalines were added in 2015 to Annex A and C. And in 2017, hexachlorobutadiene was added to Annex C. So these unintentional POPs are commonly formed as byproducts in the production of organochlorine chemicals, in processes where elemental chlorine is present, and as you know best, thermal processes in the presence of all form of chlorine. And the Article 5 of the Stockholm Convention for unintentional POPs states that each party shall reduce the total release of the chemicals listed in Annex C with the goal of their continuing minimization and where feasible, ultimate elimination. Yeah, so that's the goal for unintentional POPs in the Stockholm Convention. Now to the molecule, on the left side, the dioxins, and here the furans. Just one difference is one oxygen bridge. So they are the most known and best investigated unintentional POPs, also with the highest toxicity. They have different congeneers depending on the substitution here of chlorine. And important are especially the 17 congeneers substituted in 2, 3, and 7, 8 position, because they only include the dioxin toxicity. So when we look finally here to data and we make an inventory, we always talk about toxic equivalency, TEQs. And here this means only the 17 dioxin-like toxicity. And the concentration of these congeneers multiplied by toxic equivalency factors is finally the gram or kilogram of dioxin released in a country. So the largest dioxin furan formation came from organochlorines. So here, when you look to the PCBs, it's very easy to produce from a PCB by just an oxygen insertion to the furans. And also what is very important, the PCBs and some of the PCBs have dioxin toxicity. And when we calculate the dioxin toxicity of the total 1.5 million tons produced PCB, we have about 10,000 to 16,000 kilogram TEQ. So when you today compile all available dioxin inventories and even do an estimate for all the 190 countries, then the estimate here is about 100 kilogram TEQ of total global TEQ emission per year, 100 kilogram. And you see in history from PCB, we had a release and production of 10,000 to 16,000 kilogram. Yeah. By this, you can understand when you today look into your food, into a fish, for example, the TEQ in this food or fish comes often more than 50% from dioxin-like PCBs. This you can understand by this number. And PCBs, like I said, are furan precursors. So in thermal stress situation, like a transformer fire, they can produce in the percent range the PCDFs, the furans. And the furans are several hundred times more toxic than the PCBs. So by the formation of furans from PCBs, the total toxicity of the mixture can increase by 50 times. So therefore, it is so important to do appropriate PCB management and use appropriate facilities and understand the high risk of dioxin formation when PCBs are destroyed. Yeah, and therefore also when you have a fire with a PCB transformer, afterwards the whole thing is much more toxic. There is one building in the US in the 1960s, they had a fire. Since then, the building is closed until today. Another important source of dioxins were the production of chlorinated phenols. You might know the pesticides 2,4-D, one of the most used pesticides, or 2,4,5-T. These are phenolic pesticides, also pentachlorophenol, which have been used abundantly in leather and wood treatment. PCP has listed as new pop in 2015. So already in their production, but also then if there is thermal stress, they are producing dioxins. We have one factory in Hamburg which produced for 30 years lindane and 2,4,5-T. So this factory has disposed between 300 and 850 kilogram TEQ in landfills, and half of it is in the middle of Hamburg. So you can compare this. This is 3 to 8 times all the dioxins we produce today in a year. There's unfortunately only, or fortunately, only one historic dioxin inventory, and this comes from Japan. So Japan has done a dioxin inventory from 1957 until recently. And what you see is that in the 1960s, 70s, and 80s, about in average 30 kilogram of dioxin TEQ was emitted into the environment of Japan by the use of pentachlorophenol as a pesticide in rice fields and chloronitrophene, which also contained high dioxin levels in the 60s and 70s. So in total, about 460 kilogram of TEQ have been released into the Japanese environment, into soils, into rivers. And today even we have a contamination of Tokyo Bay in the sea because of this 460 kilogram of TEQ. As I said yesterday, that the half-life time of dioxin in the soil is not 10, 12 years. Yeah, we are talking rather about centuries. So therefore today, these dioxins which have been emitted 1960s to 1980s are today in the sediments and soils still. The same we see in Europe. So what you see here is a sediment core, and this sediment core from a lake in Switzerland has been taken in the depths that you can see the layer from 1850 to 2000. And you see in 1850, 70, 80, dioxins and PCBs were basically non-existing. But then here, starting from the 1930s, with the PCBs where production started, also the PCB levels in the sediment started. And we have a peak at the end of the 1960s, the same for the dioxins. Yeah, the largest emission in Switzerland was in the 1960s and 1970s. So the same like Japan. Yeah, so we see it in the sediments. The funny thing is that the dioxin countermeasures in Europe started in the 1980s. Yeah, so about incinerators, about metal plants. Yeah, so here the big driver of the global pollution in the world have been the use and production of PCBs and these chlorinated aromatic compounds as pesticides and so on. Yeah, and they have changed in the 1960s and 1970s. So the industry have already understood in the 1950s that dioxins are toxic. In the Hamburg facility, when they started 2,4,5-T production, after 2-3 weeks, the whole production need to be stopped because all workers were ill. Yeah. And at that time in 1956, the company in Hamburg understood, okay, it's dioxin in their 2,4,5-T production. So today, the major air releases in the different regions come mainly from open burning, followed by waste incineration and the metallurgical industry. So open burning, in particular open waste burning, is the highest dominant source today of releases to air in Africa, Asia Pacific, Latin America, and the Caribbean. And when we look to the whole life cycle of dioxins, we see, yes, we have this thermal emission, which you consider the most relevant, and maybe today in many countries, this is the main emission. Then we had all the historic production, but also we have contemporary production of organochlorines. It goes into the reservoirs like contaminated sites, landfills, soils, sediments, but also products. From there, it has environmental transport, atmosphere, to land, to the aquatic, to sediments. And from there, it accumulates in animals and in fish. And from there, finally, we have it in food ingestion. Additionally, there have been and still are exposure also, let's say, in the productions for the workers, occupational exposure and accidental exposure. I recommend you to have a look to my review articles from 2008, 2018. The 2018 one has open access, so you just can click on this. Already this morning with your breakfast, you had some dioxin exposure because it comes with food, unfortunately, with the most delicious food. So the largest share of dioxins, more than 90% of human exposure, come from food, in meat, beef, chicken, in fish, but also in cheese and butter. This means all your cheese, milk, meat you eat has some dioxin in it. Yeah, only the detection limit. Here we talk about picograms. If you have another food habit here, like Japan, the major dioxin exposure pathway in the population of Japan is here seafood by more than 50%, but also we have meat and milk. So the question is, how is the dioxin and POP exposure from food in the Middle East? Yeah, at least Kuwait, maybe tell later on, has done some studies on their food they are importing. That you see that partly in the Middle East, you have an exposure. Here are data from human milk of dioxin in green and PCB, dioxin-like PCBs in yellow. And also here you see that PCBs have about 50%, yeah, of the total TEQ, just what I told you before, from where it comes. And in the first WHO human milk study in 2003, Egypt had the highest dioxin levels. Yeah, here with over 30 picogram TEQ in human milk. But one good message, when Egypt did a second study in 2019, they had a considerable decrease to dioxins and PCBs in human milk below 10 picogram. Yeah. So when you compare the dioxin concentration in human milk with the tolerable daily intake, you see that today, still today, the human milk is 10 to 100 times above the tolerable daily intake, which you calculate. But when you compare the advantage of mother's milk, which is still the best nutrition for baby, it overcompensates this kind of contamination of POPs. So this is very important to communicate. I gave you here 2 publications and the link to these publications, and also to the WHO website, which recommend at least 6 months breastfeeding. What are the toxic effects of dioxins? At acute effects at high dose, it's chloracne, wasting syndrome, and even death for animals at quite low levels, but also humans at extreme exposure. Important for us is the daily impact we get. And this can lead to chronic effects like tumor promotion, carcinogenity, hormone system disruption, endocrine disruption, and developmental toxicity. Also immune system suppression. So it's quite complex. The picture what you see here, this is Yushchenko, the former president of Ukraine. So he was contaminated with a few milligrams of dioxins. Yeah, this was before, and this was afterwards with the chloracne. I said only one slide about formation because we do not have much time, but just for you, for the background, in all incineration, we have the formation of aromatic compounds, food, the soot, and PAHs. And then we have ashes which contain chlorine and metals. And here we get oxychlorination at temperatures between 200 and 600 degrees. And by this, the PAHs and the soot is degraded, but at the same time it's chlorinated. And this results in the formation here of dioxins and furans by the so-called de novo synthesis. And at the same time, also PCBs, PCNs, and the other chlorobenzenes are formed. Yeah, so this is formed in the same process by degradation of the PAHs and soot in all the thermal sources. So therefore, in thermal processes, dioxins and other unintentional POPs are formed together with a certain concentration range. So you have higher amount of chlorobenzene compared to the dioxins, but the dioxins are the more toxic ones. So therefore, for thermal sources, dioxins and unintentional POPs can be minimized or eliminated by the same measures that are used to address dioxin releases. And therefore, it is thus recommended by the UNEP Toolkit and Toolkit approach for practical reasons that inventory activities be focused on dioxins and furans, as these substances are indicative of the presence of other unintentional POPs in most sources, particularly the thermal sources. So for a few thermal sources, also there are emission factors of PCBs and hexachlorobenzene in the UNEP Toolkit. Yeah, emission factors of pentachlorobenzene, hexachlorobutadiene, and PCNs are not listed in the toolkit. But there are also some studies on emission factors of pentachlorobenzene and pentachloronaphthalines. Therefore, a party can do additional efforts to develop an inventory for other UPOPs. But this is rather scientific than relevant for the policy. So it is enough for you to develop a dioxin inventory and see what are the biggest sources and then address these sources. So this is the most thing what you as a policymaker need. Yeah. If additionally you want to know something on other unintentional POP, we can discuss that. Only for one source, other unintentional POPs have specific relevance, and this is the organochlorine production, which probably you do not have in Oman. Yeah, so unintentional POPs are formed in chemical processes, depends on the structure and the synthesis routes of this organochlorine chemical. So for some production processes, the formation of dioxins and furans have the high relevance. I just showed you in one of the early slides, the chlorophenols, which are directly precursors of dioxins. Yeah, but there are also some processes with high formation of other unintentional POPs, such as other unintentional POPs like PCBs or chlorobenzene. So examples there are chlorinated solvents and certain pigments. So here for the chlorinated solvents, just I tell you this example for tetrachloromethane production, tetrachloroethane production. They have high volumes of hexachlorobenzene and hexachlorobutadiene and PCNs, up to total 10,000 tons of such waste for one facility. Yeah, but this facility you do not have in Oman. For some of these organochlorine production, some emission factors, like I said, PCBs and HCB have been listed in the UNEP Toolkit. And for hexachlorobutadiene, you can look in the inventory guidance. Yeah, but as I said, only partly relevant for Oman, only for import of these chemicals. So therefore, the question is what organochlorine production you have? Probably not, but you have import and possibly use in the country of these chemicals. When we look to the Stockholm Convention, Article 5, on measures to reduce or eliminate releases of unintentional POPs, Article 5 says in paragraph A, develop an action plan within 2 years of the date of entry into force of the convention, designed to identify, characterize, and address the releases of the chemicals listed in Annex C. So this needs to be developed for the national implementation plan, and this is based on the inventory. So therefore, here the Article A in the first paragraph I says an evaluation of current and projected releases, including the development and maintenance of source inventories and release estimates, taking into consideration the sources, the source categories identified in Annex C. So therefore, the inventory development for unintentional POP is the first activity. We need first to understand which are the major sources. And therefore now in the second part of the presentation, it's about inventory development for dioxins and other unintentional POP releases with the UNEP Toolkit. So over the years, UNEP has developed a toolkit with emission factor methodology for identification and quantification of releases of dioxins and furans, and also some of the other UPOPs. This is very important because most developing countries and also many other countries do not have really measurements of their dioxin releases from facilities. So therefore here the toolkit has developed a methodology where you can, which assist parties in establishing release inventories that are consistent in format and content, ensuring that it is possible to compare results, identify priorities, mark progress, and follow changes over the time on the national level, but also even on the regional or global level. So here, emission factors have been developed for all relevant sources, and these emission factors are compiled in this toolkit. And Oman has already used the 2005 toolkit for their first inventory. So we have now an updated toolkit. This is really better, and also there is an online format. It's much easier to handle. We have here a part A, which gives you general guidance. So here you can read on the background about data quality, about guidance on updating and revising inventories, and also about reporting of the inventory results. Then, very important for the inventory is part 2, the default emission factors. So they include all emission factors. Some of them have been revised or are new. Also, they give guidance on estimated activity rates and classification of sources and assessing appropriate emission factors then for these sources. And we have a very big part 3. You not necessarily have to look at, but in this part 3, you have all the background information, how the emission factors have been calculated. And also it contains example inventories for the different source groups, where you can have a look how other countries have developed a certain inventory, for example, for the metal industry or for incinerators. So what you need to calculate is finally the dioxin release per year in the country. And this is by calculating the dioxin release of individual sources. So here you would gather activity statistics, which describe quantity of processes. For example, how much tons of hospital waste has been incinerated, or how much tons of steel have been produced per year. And then the toolkit is give you the emission factor, which are describing the amount of dioxin released to air and also on the residues, for example. So what you need to do is, yes, to gather the activity statistics and then multiplying with the emission factors. And by multiplying the respective emission factors for the different sources, then you get the milligram and gram of dioxins for the individual sources. Yeah, And then by summing of all these sources, finally, you can calculate the total dioxin release. So therefore, what you will do is to look for the activity rates, the amount of waste incinerated, the amount of steel produced or copper produced. So these are non-dioxin-like numbers. They are country-specific and facility-specific. You can get them from economic data, from statistics, from individual plants. And the data, this data compilation, this is the main task of the unintentional POPs, the dioxin inventory team you will gather. And then you need to gather also some information that you can decide on the emission factors. The emission factors are identical for similar technology. So a good incineration, a good incinerator in Oman and a good incinerator in Germany emit the same dioxins. Yeah, a bad incinerator in Oman and a bad incinerator in Germany emit the same amount of dioxins. So these default emission factors are provided in the toolkit. But also, if you have measured data, you can also use measured data. Yeah, so it can go both. You can do hybrid. Yeah, if you have for some sources good measurements, you can use the measurements for calculation. If for some of the sources you do not have measurements, for those you can use the toolkit. The step one is first to look what are the main source groups you have in your country. And here the toolkit has compiled 10 different source groups according to the Annex C of the Stockholm Convention. This includes waste incineration, ferrous, non-ferrous metal production, power generation, production of mineral products, transport, uncontrolled combustion, production and use of chemicals and goods, disposal and identification of hotspots. The largest emission are normally from category 1 incineration, category 2 ferrous metal and non-ferrous metal, and uncontrolled combustion. And depending on the country, it can also come from chemicals. And what the toolkit has is different emission factors for the different main release routes. For example, incinerator has releases to air, but also on the ashes. So therefore, you have here emission factors for air and ashes. Yeah, and this depends on the different on the different sources, what kind of emission factors is given by the toolkit. At the same time, these sources also emit heavy metals like mercury or lead, but also particulate matter, PAHs, and greenhouse gases. Yeah, and I always say to country, if possible, you should think on an integrated approach. Yeah, for example, also Oman will have to do finally a mercury initial assessment. Yeah, and many of the dioxin sources like waste incineration or power plants or metal plants at the same time emit mercury. Yeah, so therefore, yes, you do a dioxin inventory, but consider to link inventories. For example, you have an inventory for greenhouse gases, which cover many of these sources. It's good to link these kind of inventories and thinking. So within the different source groups, you have different source categories. Yeah, for example, here for the waste incinerator, you have municipal waste incinerators, hazardous waste incinerators, medical waste incinerators. So this is the whole matrix of the toolkit, the different source categories within the different 10 source groups. I just go to 2 of these source groups and look to the source categories. Here first to source group 1, waste incineration. And what you see here, yes, we have 7 different types, but I have looked here to Oman and I have seen, okay, Oman in your first inventory, you only had medical waste incineration. So maybe still you might only have medical waste incineration, but maybe in the last 10 years you have built a municipal waste incinerator. Yeah. So here you would need to check, okay, what waste incinerator type we are operating in Oman. Yeah. And then for each of these incinerator, then you would look to the activity rate. How much waste is this medical waste incinerator incinerating? The same for source groups 2, ferrous, non-ferrous metal production. Also here I looked in the Oman inventory, in the first inventory. So at that time you had iron and steel production, you had copper production. And the Oman NIP told at that time that Oman is planning to produce a sinter plant. Yeah, so maybe when you are doing now the inventory and you have built your sinter plant, then you can also add the calculation of those. One area I highlight and which often countries forget is the thermal wire reclamation. So you have copper cables in electronic waste, and normally they are recycled. And often this is just done by informal sector. This has a quite high dioxin release. So therefore, it's interesting also in Oman to see if there is any of this activity in your country, and how much of these cables are burned. So overall, there is a 5-step approach for establishing the dioxin inventory. So first, use the screening matrix as a guide for identifying source groups. So you have seen the 10 source groups. I have already shown you, and already in the first inventory, you have done that. Then come the source categories. Yeah, this is like in the waste incineration, you have different type of waste incineration. So you check what kind of source categories are present in Oman. Yeah, and then in the next step, you obtain information on the individual sources. Yeah, so this means you go to the individual hospital waste incinerator to understand how much waste do they incinerate. You might get it from the health ministry, but also you need to understand what is the technology of the individual incinerators. I think last time you had about 10 medical waste incinerators, hospital waste incinerators. Yeah, and then by understanding the technology, you can select the emission factor. Yeah, and the 4th step is then just you quantify. Yeah, you multiply the emission factor with the activity rate. Yeah, and this you do for all individual sources. And finally, when you compile everything together, you have established the full dioxin inventory. Going a little bit into this detail, we stay with the hospital waste incineration because it's present in Oman. So the toolkit has for the individual source categories, individual technology levels, and the individual technology levels have different emission factors. So if you have a real bad hospital waste incinerator, the air emission can go up to 40,000 microgram TEQ per ton waste. Yeah. If you have a high technology combustion, which is operating continuously and has air pollution control devices, the emission to air is here just 1 microgram TEQ. Yeah. So here the main is then finally in the ash. Yeah. So what you need to do is then for your 10 incinerator to understand what are the technology levels for the individual incinerator. And by this, you then can finally select here the emission factor. And finally, then you can calculate here the total dioxin release from your hospital waste incinerators. Yeah. For example, you would find that some of your hospital waste incinerators are really bad. This means emission factor of the lowest class. And then you will find how much tons is incinerated. We take 10,000, that's probably too high for Oman. And then this would be then multiplied with the emission factor 400 gram TEQ per year. Yeah. If you have a controlled batch incinerator, the emission factor is much lower. And for the same amount of waste incinerator, you only would have 30 gram TEQ per year. Yeah. And by this, finally, add up the different facilities, you get the total amount of releases from your hospital waste. There is an Excel table. Maybe later on we can have a quick look to this Excel table for calculation. And also, maybe if we have time later on, I can also go into the toolkit and show you where you find it. Otherwise, we might have with your unintentional POP team own session later. What is important is the baseline release inventory. And this baseline release estimate is the first inventory which in Oman you already have done. Yeah, so this you have compiled more than 10 years ago and was part of your first national implementation plan. So this baseline inventory serves as a baseline against all further inventories for the establishment of trends over time. Because by this you can evaluate the efficiency and efficacy of the strategies which were adopted for the continuous reduction and elimination of dioxin and other unintentional POPs as required by Article 5 of the Stockholm Convention. So now your baseline inventory need to be updated with the updated toolkit emission factors, because some of the emission factors have changed. Yeah, and the new inventory you will calculate with this toolkit and with the new emission factors, and that you can do a real comparison. You need to calculate also your baseline inventory with the updated toolkit. Yeah, so here you need to go back to the old inventory. I already had a bit of look into your inventory in Oman, and I just take one example. So here in Oman, when you did your first inventory, you took the data for vehicle fires from your 2002 data. At that time, you had 292 vehicles which were destroyed by fires or which had a fire. And there was a proposed emission factor of 94 microgram TEQ per vehicle. Yeah. And then today, when you will do the update, you will check how much of vehicles have been burned in the inventory year you choose. Probably you will choose 2020 or 2019. It depends where you have the data halfway complete. And now the toolkit 2013 has changed a little bit the emission factor. So instead of 94 microgram TEQ, it is 100 microgram TEQ. So you will calculate here your vehicle fires, but also in addition, you need to revise the baseline inventory. So here, the 292 vehicles in the baseline inventory, you recalculate with the 100 microgram. So now you will get 0.029 gram instead of the old inventory 0.0274. And this you will then compare, and you will understand, okay, did we have increase or decrease for that source, yeah, or then for the total inventory. Another example relevant for Oman I have checked is that the 2005 toolkit had no emission factor for catalytic oil cracking. So the toolkit 2030 includes now an emission factor for this oil cracking to produce naphtha. Therefore, also when you do now a calculation here for the updated inventory, you should also go back to your old data from the inventory year of the baseline inventory and also calculate what was the dioxin emission of cracking of this oil. Yeah, and then you can compare. So in the 2013 toolkit, the updated emission factors are marked in red. So you see immediately, and only a few emission factors have changed. Yeah, most emission factors are still the same. Yeah, so there will not be, it will not be a big work to do an update of your baseline inventory. Good. Then as a last part, like I said, the dioxins are unfortunately very persistent in the environment. So therefore, the dioxins which have been released the last 50 years are still, most of it is still there in soils and sediments and contaminated sites. So therefore, also the UNEP Toolkit has a source group 10 on contaminated sites, and the Article 6 of the Stockholm Convention encourages parties to develop strategies to identify sites contaminated with POPs, yeah, here with unintentional POPs. So in the toolkit, the source group includes already an indicative list of activities that might have resulted in the contamination of soils and sediments with dioxins and other unintentional POPs. So these dioxins from reservoirs includes contaminated sites and hotspots, represents nowadays an important source of human exposure. Yeah, I had a project for the German government 2012 to 2015 where we checked environmental pollution and exposure to food and food animals, including, for example, chickens. And you see the chickens pick the soil and the dioxins in the soil go into the egg. So this you find all over in the world. And here I really recommend you to read this review article. It's quite comprehensive and interesting. So this procedure comprises 3 tasks. For the source group 10, identify historic activities that could have caused contamination and identifying the potentially contaminated sites. For Oman, for example, you mentioned in your NIP that you had transformer fires before. So if PCB have been involved, this is for sure a dioxin furan contaminated sites. Then assessing these sites for the likely magnitude of the contamination and ranking by their exposure risk. So here, if you have a transformer fire and somewhere polluted site, potential polluted site, it might be interesting to discuss with Kieser and Dr. Hassan if you can analyze some of these soils also nearby, and then assessing the degree of contamination of the most significant sites by detailed analysis. So I don't know how much Oman has looked into contaminated site topic, but industrial countries, we have looked into this topic for the last 40 years or so. You can look to the US Superfund project, the last 40 years. Also Germany, we started more than 35 years ago. Also other countries, and what we see is we need to continue. So in Europe, for example, in total, we have 3 million potentially contaminated sites, 3 million, yeah. And it's really challenging then when industries change, you stop an industry, then you redevelop the area. These contaminated sites are a real headache. So therefore, if you are interested in contaminated sites, dioxin contaminated sites, we had a series on dioxin UPOP contaminated sites, and here are the link to some of these articles. And we always need to remember, yes, dioxin is one important emission for incinerators and for metal industries, but at the same time, we have heavy metal emission, we have PAH emission, polyaromatic hydrocarbons, we have emission from these sources of particulate matters. For some of the sources, the heavy metals are more important than the unintentional POPs. Yeah. So therefore, when you are looking to emissions, I recommend you, maybe now not for the first activity, but overall to think in an integrated way to the emissions and the pollutions in addition to dioxins and unintentional POPs. So when you look to all the sources and the life cycle, you will find that best available technology, best environmental practice, and waste management is the key to reduce and minimize. And here we have the UNEP BAT-BEP guidance for Annex C chemicals, which can help you to solve the releases and these problems. Conclusions and step forward. Oman has a baseline dioxin inventory. So this baseline inventory, please recalculate with the Toolkit 2013. Then develop a new dioxin inventory for a selected inventory year, maybe 2020, but we can discuss. Assessment what source groups and source categories are present in Oman, gathering the activity rates of individual source categories, classify individual sources according to the situation of the individual plants and industries to select appropriate emission factors, do an assessment of the source group 10 on contaminated sites and related risk and exposure for humans and food animals and wildlife. The dioxin toolkit has included some emission factors of other UPOPs, so it might be calculated, but like I said, I rather would see this as an interesting task for a university. Please make sure that the detailed data of this inventory is kept in an appropriate database that is available when updating this baseline inventory. Yeah, so emission factor of the UNEP toolkit might change, so a reassessment of inventory might be needed. Thank you for your attention. And then I have the first question. Do you have all the data from your baseline inventory in the Excel table?
Thank you so much, Dr. Roland Weber. Now the floor is open for discussion, and he opened a question like to, I guess, to Dr. Muhammad Al-Kasbi.
Thank you, Roland, and thanks, Yasser. Actually, it's clear, but I think I suggest from here our side to have another workshop for only toolkits training. I think it's better separated than this workshop to how we can like the application, how we can use it, and following, and even with examples, and we can use what we I mean, if you can use our available data, and also even we can practice it with 2006 or 8 UNEP data. If you could do it to understand how we can use the toolkits.
Okay.
Different. I mean, we can. We're going to decide when this workshop can be run it in future after this workshop.
Yeah. Okay, yeah, but let's say that will be a different discussion, but maybe Hassan will facilitate. Yeah, okay, yeah, good. So maybe Shireen, you can share your.
حضرتك هتلاقي الإجابة كمان دقيقتين بالظبط على اللي أنت عايزه. حضرتك مستعجل شوية بس الإجابة هتلاقيها دلوقتي.
ممتاز.
أوكي، ما تقلقش.
طبعا Roland Muhammad, he wanted another workshop, so when he have some data, his idea, he will gather some information, and when that he have that information, he need another workshop. Anyway, we can arrange this later on. Yasser, floor with you.
I think Dr. Hassan has, Dr. Azhar has raised her hand. So if she has any question, please go ahead. Dr. Azhar.
Yes, thank you for your very clear presentation. And I wanted to ask about these emission factors. It is provided in the website, or from where we can get, which is 25 or 2030?
Yes. So wait a moment, I can share my screen. First, the toolkit is online. Yeah. So you just can wait a moment. Where do we start? So you just can go in the website and look for the UNEP Toolkit. Yeah. So it is really online, but also it is available on CD. So can you see my screen?
Yes.
Yeah. So what you see here, wait, I need to move this. So this is here now the toolkit. Yeah, maybe we go first to the main page. The main page. So in the main page, you see here, this is first the introduction. And wait a moment, I can also use the, no, I cannot use this one. And then we have here part 1 with the general guidance. You can click on, and then you can read about the general guidance. You can go to the default emission factors. So here more, then you click on default emission factors, and then it brings you here to the part 2 default emission factors. And you see here you have all sources: waste incineration, metal industry, power plants, mineral production, transport, open burning. So we just go into, let's say, the waste incineration. So then here it tells you what are the different source categories. You see here, wait a moment, I make it a little bit larger. So municipal solid waste incineration, the different source categories. And then you can go down and then you can go to the individual source categories. So you see here, we go to the medical waste incinerator because you have it. I click on it, then it opens, and then it tells you the background of this medical waste incinerator, and then it tells you what are the different emission factors for the different classes here, uncontrolled batch type, controlled batch type, and here are the emission factors then. And it also gives you guidance for classification of the sources. So it tells you class 1 includes very small and simple small box type incinerators, operated intermittently. This means only for a few hours. Yeah. So no temperature control, no air pollution control. Yeah. So also this toolkit explain you and help you a bit to understand what category is the individual incinerator, the same for the metal industry. Yeah. And even you see, it gives you some suggestion where you can get the activity rates. So you see here activity rates for municipal waste incineration might be obtained, for example, from the Ministry of Health, yeah, from the state, provincial, from the hospitals. Yeah. Okay. So all this you can find and you can very easily navigate. Yeah. Here, metal industry, just background, what type of metal industries, and then it comes to the individual sources. Yeah, here copper production, and then background on the copper production, primary, secondary. Here are the emission factors. Yeah, and also the guidance to classify the sources, and then how to get the activity rates. Yeah, so you see that this new toolkit is really super in this respect. Yeah, it really supports and give you guidance.
Thank you very much. But according to this will need some data for calculations, yeah?
Yeah, sure. I said you need the activity rate. I mean, you can only calculate the emission from an incinerator when you know how much waste it has incinerated. Yeah, this is what you need to know. And then you need to know, you need to check the quality of the incinerator or the metal industry. Yeah, I mean, does it has a air pollution control device? Is it operating continuously, or is it just operated a few hours with stop and startup? So this is the internet web page. Yeah, toolkit. Yeah, wait a moment. When I click, so it's just the same toolkit like on my laptop. Yeah, so I just send you the link in the chat. Where is the chat? Here's the chat. So toolkit. UNEP Toolkit 2013. Okay, yeah. So you can have a look and you can check out, yeah. And even there is a film how to update the inventory, yeah. So here you can click on this small explanatory film. Okay, other questions?
Yes, if you could, about if you have any Excel file for these all calculations required.
Sure. Yes, so the Excel file is also here. You can download from the website, and also the new UNEP toolkit has the Excel with the 2013 emission factors. So you see here we are in the Excel. We are in group 1. Maybe again, we go to medical waste incineration. Yeah, and we just take our example, medical waste incineration, and you have here all different subcategories. Yeah, uncontrolled batch combustion, controlled batch. So if we, for example, choose here, like my example with the 10,000 tons, it calculates you at the same time the emission here 30 gram of dioxins per year, and you have the main page, and also here in this main table, when you include for the different source groups the different amount of tons incinerated or metals produced, it directly calculates you the total amount into the main table. Yeah, so that's really very much convenient. And finally, in your UNEP, you should have finally two of these tables. One is the new table from the new inventory field, and the other is the baseline inventory with the updated emission factors from 2013. And then you can very, very nicely compare the two inventories.
Ronald, I think you opened something other than this website, an Excel file or something.
You can't see the Excel?
No.
Okay. Wait a moment, then I need to go out, and again I need to share screen, and then I need to go to the Excel. Yeah, now you can see the Excel?
Yes.
Okay, so what I have shown was just for source group 1. Yeah, source group 1 is incineration. So you have all different source groups, source categories of incinerators here. And then also for the individual incinerators, like here, medical waste incinerator, you have the different types and the different emission factors. And the only thing you need to do is here to include the activity rates you find by asking to the hospitals how much waste you have incinerated for this and that year. Yeah. And so here I just included then the 10,000 tons. Yeah, so it automatically calculates you then the dioxin emission to air and the dioxin emission to the residue. And the same is then transferred directly automatically to the main table here for waste incineration. Here you find again the 30 grams emission to air and how much is going to the residues. Yeah, so this is quite convenient from this Excel table from the toolkit. Good.
Thank you.
Yeah, very welcome.
Okay. Yeah, we had a great interactive session now.